Chapter 14. We are going to be talking about graphing trigonometric functions. We are only in Algebra 2 Trig going to talk about graphing sine and cosine functions. And we're going to start in 14.1 with just some pretty basic sine and cosine things. So like we usually do, let's make a table of values to see what the shape of the graph is. Now, the thing is that theta is an angle measurement. So instead of substituting in values like -2, -1, 0, 1, and 2, let's put in critical values for theta. Those are maybe quadrantal angles from the unit circle would be really easy to do. So let's think about what sine of 0 would be. Well, sine of 0 is 0. How about sine of pi over 2? Well, sine of pi over 2 would be on the unit circle, if you think about it. Remember, would be up here. So the y value would be 1. How about the sine of pi? Well, that would be 0. How about the sine of 3 pi over 2? Well, the y value would be -1. And how about the sine of 2 pi? That would be 0. So let's plot those points. So let's start by labeling the graph with those quadrantal angles. Pi over 2, pi, 3 pi over 2, and 2 pi. So that means over here we would have negative pi over 2. And notice that the y values really only range, in this case, from -1 to 1. And let's plot that and see what happens. We have 0, 0, pi halves 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Now what happens though is that when we connect these, it's not a sharp linear type of a thing, but it's a beautiful smooth curve. And that's what the sine graph looks like. Now the thing is that the only values for theta aren't just 0 to 2 pi. That continues. So if we were to continue, if you think about the unit circle, isn't it going to repeat those same values over and over and over again? So what we do is we're going to extend these a little bit and put arrows. And that's what is expected of you guys to do for a sine graph. But I do want to point out that if we did have anything else, it would continue to be graphed in this fashion. So we would go over another pi over 2, and it would be 1. Go another pi over 2, and it would be 0. So notice that what happens is that it's this continuous curve, okay? And so oftentimes people talk about like a sine wave, so notice that this looks like waves, these never-ending waves. These extend, these repeats in both directions. It is called cyclical that way, okay? So it keeps cycling over and over and over. But that's the basic shape of the sine graph. So now let's think about cosine. Remember, cosine are the x values. So if we think about the cosine of 0, that would be 1. The cosine of pi over 2 would be 0. The cosine of pi would be -1. 3 pi over 2 would be 0. And 2 pi, we'd be back at 1. So once again, we'll label the x-axis with those quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi. And the y, notice again, we just have values from -1 to 1. So this time, we start at 0, 1, go to pi halves 0, pi -1, 3 pi over 2, 0, and 2 pi, 1. So I understand that it looks like a V shape, but it's not. It actually is going to have that nice curve shape. So it curves around like this. Okay? So it doesn't curve inward here. We want to keep kind of curving outward and scoop up like this. Now, when we think about what happens, we don't just put arrows up like this. That is not what happens to cosine. Yuck. Okay? what's going to happen is that this is going to come back down. So when we make our arrows for the cosine, it's very important that it curves back down after you do one of these cycles, because what's going to happen is that this is going to cycle back down this way. This is going to cycle back down this way, okay? So the gist of the cosine is that when you have your arrows, make sure that you have the arrows pointing back down, okay? So they're very similar to each other. Again, the cosine is also a wave. The thing is that they differentiate a little bit. So let's look at those characteristics here to differentiate them, okay? So the characteristics of sine of x, y equals sine of x and y equals cosine of x. Notice that sine starts at 0 and goes up to 1. And then it completes the cycle, 0, negative 1, 0. Cosine, remember, starts at 1 and goes down to 0. Okay? So sine starts at 0, cosine starts at 1, and then you just keep that pattern. Now, when we talk about the domain of each function, the domain of each function is still all real numbers. You can just write it like this if you want. You can write it in interval notation. Because remember, these radians, like radians are numbers, guys. So the domain of each function is all real numbers because these cycles keep repeating forever in each direction. But notice that the range of each function is bound between negative 1 and 1. So if you're writing this in using inequalities, we can say that y is greater than or equal to negative 1 and less than or equal to 1 this way. Or you can use interval notation, and you want to have negative 1 and 1, but remember, use the square brackets to include them. Okay. Now the amplitude we're going to see is like the stretch in the graph. It's half the difference between the maximum and minimum. And when we look at our maximum 1 and our minimum negative 1, 1 minus negative 1 is 2. So our amplitude here is 1. And again, the amplitude is like a stretch of the graph. Notice that in these very basic graphs from the axis, we're only moving by 1 above and 1 below the axis at the high and low points. So that's the amplitude. Now, each function is periodic, which means that the graph actually has a repeating pattern that we've established, and that's due to the structure of the unit circle. So the shortest repeating portion of the graph, I think I referred to this word before, is called a cycle, okay? So we are graphing one cycle of the graph, okay? And the horizontal length of that cycle is called a period. So one period is how long it takes you to get through one cycle. And here, notice we start at 0 and get to 2 pi in each of the cases. So in these basic parent trig functions, our period is 2 pi. So the only things we're going to do today are change amplitude and change period. So the A denotes a change in amplitude. So notice that we'll see here that our A is that coefficient of sine and cosine. It's like a vertical stretch of the graph. It affects the max and min. So that means that if we had a 2 in front of the sine, instead of going up to 1, we'd go up to 2. Instead of going to negative 1, we'd go to negative 2. Okay? Same thing with cosine. We'll practice that together. And then the thing that requires a little bit of quote-unquote work is the change in period. It's the B value, which is kind of new to us, helps us determine a change in period. Notice the B is not in front of the trig function. The B is in front of the x. So y equals sine B of x, B times x, and y equals cosine bx is what is going to denote a change in period. Now, a normal period is 2 pi. That was the period of our parent functions. So to find the period, what we're going to take is 2 pi over the absolute value of b. I don't believe I give you any negative b's in this course, but this is definitely something I want you to write on the side, that the period is 2 pi over b. That's like a big thing we'll be using, okay? Now, the normal critical values of theta, so when we are graphing the parent functions, we use quadrantal angles at pi over 2, pi, so we've been every pi over 2. So if we change the period, that means that we have to change those other values also. So I refer to these as increments. So here our increments are by pi over 2. But if we change the period, we'd also want to change our increments. So these are increments that exist on the x-axis. And to find those, what we do is we'll take pi over 2, our original increments, and divide by b. So our original period was 2 pi, so we divide by b to get the new period. Our original increments were pi over 2. We'll divide by b to get the new period. Just kidding, the new increments. And remember, when we divide by something, it's like multiplying by the reciprocal. So just know that when we take pi over 2 divided by b, that is equivalent to multiplying by 1 over b, the reciprocal. And so we'll practice that together. Okay? So here are the steps to graph trig functions in the form y equals a sine bx or y equals a cosine of bx. So the first thing, we think about the shape of our parent function. We'll use the a value to show the amplitude and the b value to determine the periods and the increment to use on the graph. Okay? So in example 1, we want to graph this function, and it's y equals 3 times the cosine of x. So we notice that we have an a value of 3. Okay? So our a is 3. So that means that our plus or minus 1 is going to change to plus or minus 3. That will be like a vertical stretch of the graph. And we know that cosine starts at 1. So instead of starting at 1, what we'll do is we'll start at 3. 1, 2, 3. And notice it says don't mark units on the x-axis yet. So we're going to start at 3. We go down to 0. Then we would go down to negative 3, 0, and then back up to 3. And then we make that nice cosine curve. And that's a graph. Now we are not done because we did not mark anything on the x-axis yet. And so we're going to use the b value to determine the period and the increments. Our b value here is 1. That means that there is no change in period, okay? But anytime there's a b value, we take 2 pi over the period. Sorry, over the b value. 2 pi over the b value, and that gives us our period. So our period is going to be 2 pi, and then our increments, again, will stay the same. Our increments will be pi over 2. So that means just like we did on the front, we'll have pi over 2, pi, 3 pi over 2, and 2 pi. And so those are things that you need. You want to make sure that you are including the amplitude in your graph and that you're including these increments on the x-axis. And that's our graph for example 1. Oh, let's also talk about the domain and range. Our domain here would be all real numbers. And notice our range has been adjusted because of this. Our range is now negative 3 to 3 on the y. So one of the things is because it's textbook homework, I don't believe it asks you about the domain and range. That's a nice thing just to remind yourself of. If we're doing it in the notes, it will be on a quiz, okay? Let's try letter B. Let's do y equals 5 times the sine of x. So first we see that sine is going to start at 0. So we know sine starts at 0. And we notice that our a value is 5 because it comes before the trig function. So that means that any 1s are going to turn into 5s, that this, again, is a stretch. So sine started at 0 and then went up to 1. So that means that instead we're going to go up to 1, 2, 3, 4, 5. Back down to 0, down to -5, back up to 0. And so then we draw our sine curve with the arrows. Okay? Oh, real quick, let me mark that we just went by 1s on the y-axis in both example 1a and b, sorry. Okay? Notice that the arrows for the cosine function went down because these are the maximum points, but for sine, notice that it goes in the different directions there. Now, we're not done because we still have to do step 3. Use the b value to determine the period in increments. And notice that our b value is 1. And when our b value is 1, those things don't change. So that means that our increments will still be at pi over 2. So we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And I'm a good student, so I'm going to label back here also. Okay? So notice in example 1, the only thing affected was the amplitude. Okay? Amplitude is the stretch or shrink of the graph. So now let's look at example 2. Notice in example 2, our a value in each case is 1, so there's not going to be a stretch or shrink, but the b value is different, so we'll have a different increments. Okay? So we notice that this is a sine function, and so we know the sine function, starts at 0. We notice our a is 1, so there's no stretch or shrink. So for the sine function, we'll start at 0, go up to 1, down to 0, down to -1, back up to 0, and this is what our sine function looks like. Okay? And so I don't forget, I'll just label the y-axis with 1 and -1. But now notice that the b value is different. Our b value is 3. And so that means that we're going to take 2 pi divided by 3 to get our period. Now that doesn't reduce, so that means that our period is 2 pi. So to get the increments, so I don't want to label this pi over 2 anymore. I have to count differently because of this 3. I'm going to take pi over 2 over 3. Remember that dividing by 3 is like multiplying by the reciprocal 1/3. And so that gives me pi over 6 as my increment. So that means I'm going to count by pi sixths. Let's do that very carefully. Here's 1 pi sixth. This would be 2 pi sixths, but 2 pi sixths reduces to pi over 3. Next would be 3 pi sixths, but 3 pi sixths is like pi over 2. Next would be 4 pi sixths. 4 pi sixths would be 2 pi over 3. And notice that this fourth value should match that period. Notice that that's how long it took to make one full cycle. And then over here, I'll just put negative pi 6. So that's the gist there with affecting the period. We just label our x-axis differently, and we're all set. Let's just look at the domain and range for this function. Here, our domain, again, is all real numbers. And then our range goes from, there was no stretch or shrink, so our range is just going from -1 to 1. And I know I didn't do the domain and range for 1b, but I think you get the gist, but we just do a couple. Okay? So let's do example 2b. This one also is affecting the period. pi is a number, all right? So let's attack this. So first, let's think about the shape. We know that cosine starts at 1. We look at the a value, which is in front of the trig function. We see that a is 1. That means there's no stretch or shrink. So we'll start at 1. We'll go to 0, -1, 0, 1. And we'll make that nice cosine graph. Okay. So there's the shape of the cosine, but I need to know how it's been stretched or shrunk horizontally. Okay, so there's no vertical stretch or shrink, but we look here and we see that the b value is pi. We said that to find the period, we're going to take 2 pi over b. So we'll take 2 pi over pi. So that gives me a period of 2. I know there's no pi there. That's okay. All right. Now let's find our increments. For the increments, we take pi over 2 and divide it by b. So we'll take pi over 2 divided by pi. Remember that dividing by pi is like multiplying by 1 over pi. And notice that those cancel, and we have 1/2 as the increments. So now we're going to count by halves. I have 1/2, 2/2, which is 1, 3/2, 4/2, which is 2. Again, notice that this fourth value should match the period, and then you know that you counted correctly. And then over here, I'll put -1/2. Oh, let me label this as -1 and 1 also on my axis, okay? Again, the domain for this would be all real numbers because it keeps cycling forever in both directions. Range would be -1 to 1 inclusive, all right? So example 2 only affected the b value. Example 3, notice we have an a and a b value. So let's put these things together. So first of all, we have y equals 1/4 sine of pi x. So sine means we're going to start at 0. Okay. Now, I notice that a is 1/4. So that means that any plus or minus 1s are instead going to be plus or minus 1/4 instead. So we can tell that that's going to be a shrink of the graph. So I left this open, and I think I did that on your homework template too. So let's say that this was 1. Then that means that I'd have to divide those into little fourths there. And so that means that I would start at 0 and go up only to 1/4, down to 0, down to -1/4, and back up to 0. So notice you can see when you connect this that this has been vertically shrunk. However, we also need to label this axis. So I notice that my b value is pi. So to find the period, I'm going to take 2 pi over b. So 2 pi over pi. So that's going to give us 2 as the period. And then pi over 2 for the increment over b. So pi over 2 over pi, again, is pi over 2 times the reciprocal 1 over pi. And so I get 1/2 as the increment. So I'll count by halves. 1/2, 2/2 is 1, 3/2, 4/2 is 2, -1/2 here. And that's our nice graph of y equals 1/4 times the sine of pi x. It's not that bad, is it? Our domain, of course, would be all real numbers. And the range, notice there was a shrink, and we only went from -1/4 to 1/4. And again, it doesn't matter to me in a quiz situation which one you use, but you should be consistent. If you're using the R for all real numbers, you should use the inequality. If you're using the interval notation for all real numbers, then you should use interval notation for the range, okay? I mean, that's it. All right, so let's try letter B. Y equals 3 times the cosine of 4x. So again, step 1, think about the shape of the parent function. So we know, oops, the cosine starts at, which one? Starts at 1, okay? However, we see that A is 3. So that means that our plus or minus 1s change to plus or minus 3. And that would be like a vertical stretch of the graph, okay? And so here we want to make sure that when, because of that stretch, we know that cosine starts at 1, but remember that 1 stretched to 3. So I'm going to start at 3. And then we know cosine starts at 1, goes to 0, then goes to negative 1. Oh my gosh, guys, sorry. This would be negative 1. So then this would be negative 3 to 0, and then up to 3. So again, instead of going 1, 0, negative 1, 0, 1, it'll go 3, 0, negative 3, 0, 3. Again, please make it curved. I have no artistic ability, and I don't think that my cosine and sine graphs look that horrible, okay? Maybe this one does. But that's about it, okay? So that is the shape of our graph. And now we want to find the period. So we identify our b value. The coefficient of x is 4. So that means that we're going to have to take 2 pi over b. And notice that reduces to pi halves. That's our period. Now to find the increments, how do I mark up that x-axis? I'm going to take pi over 2 over 4, since that's our b value. And dividing by 4 is like multiplying by 1/4. So I multiply across. That gives me pi eighths as the increments. So that means the first tick mark is going to be pi eighths. The next one would be 2 pi eighths. 2 eighths is like 1/4, so I'll reduce that to pi fourths. 3 pi eighths does not reduce, so I'll label that as 3 pi eighths. 4 pi eighths would be like pi over 2. And then I have negative pi eighths. Okay? And that's it. That's what the graph looks like. I'll do one more domain and range here. The domain here, of course, for all of these is going to be all real numbers. And then what would the range be here? This time, since it was a stretch, we would be going from negative 3 to 3. So notice that regardless of if it's sine or cosine, the domain and range are very similar to each other. Okay? So take a second and pause the video, try the U-tries, and then we can put those are up in a second, okay? Okay, so here's how this should look. In this U-try, the cosine starts at 1, but notice I stretched it to 2. My period was 2, my increment was 1/2. My graph looks like this. And in U-try B, I stretched to 5/2. Oh, it was sine, I started at 0. I stretched to 5/2, which is like 2.5. I did my work for my period and increments here. My increments are pi over 4, and the period was pi. So there are a couple different ways you can do that. This is how I've had the most success with my kids. I really like finding the period, then finding the increment, and then making sure that the fourth value that you label matches that, okay? So you only have to graph one period at this point. I would love to have you graph 2, but I'm going to be happy with 1 period, like so 1 full cycle, okay? All right, good luck. Have a great one.